Hello and welcome back. We're working on Chapter 1, Section 5, Properties of Exponents, and I'm going to be doing some of the practice problems from this section. In the textbook, this is on page 38, and I think it's page 39 in the PDF. I think it's like off by one, but either way you can find it. I want to do problems 10 through 17 where we're going to simplify these expressions. And before I start to just get at it, I want to talk about what that means to simplify. I wasn't, when we were talking about the properties in the previous video, I wasn't really explicit with what it means to simplify these. Essentially, what you need to look for is making sure that you don't have parentheses. Simplified expressions usually don't have parentheses as a rule of thumb. And also, like we're going to try to like make sure that the variables that are the same are going to be put together somehow. Now, when we're like adding, that's where the phrase combine like terms comes in. So we're doing kind of the same idea except with the exponents and the multiplying that's happening with this. Because everything in here is being multiplied. That's being multiplied by that, being multiplied by that. This product is then being raised to the second power. The other thing that we're going to do is if we have a constant, that'd be the -3 or maybe that 5 or maybe that 10. If we have a constant that is raised to a power, then we want to simplify that too. Okay, so let's get started. Oh, sorry, one more thing. There's more than one way to do this. As I showed you in the previous video, sometimes you can go about it in different ways. And as long as you're not breaking any of the rules, the properties, you should be okay. This is where if we were actually physically in class, I would probably have you work on these with your partner, and then I would then, after you work on it, sorry, after you would work on it with your partner, then I would show you what you should have done, and we would talk about maybe if I did something different than what you did. It doesn't mean that what you did was wrong. It's just a different way of doing it. So what I want you to think about while we're doing this is, if you want to consider this, is pausing the video, trying to simplify each of these, and then starting the video up again to see if what I did is what you did. So I'll try to keep that in mind. I won't pause myself, but I'll give a little break or something and say, okay, now you might want to pause. All right, so let's get started with problem number 10. So like pause, do the problem. Okay, so maybe you hit play again and you're back. Okay, so basically what this is like I said, this is a product raised to a power. So it's -3 times a to the second power times b to the third power times itself, times -3 times a to the second power times b to the third power. And if you wanted to expand it all out and write it that way, that's perfectly okay. The properties are there to help understand what's really going on, but also I want you to like have a good feel for what the exponents are. So either way is okay right now. Notice that since I do have a product raised to a power, I can share that exponent with each of those individual factors. So I'm going to get -3 to the second power times a to the second power to the second power times b to the third power to the second power. So the -3a squared b cubed, each of these factors gets that exponent. Now I can simplify this. -3 to the second power, -3 times -3 is +9. So I'm going to write 9. A to the second power raised to the second power means a squared times a squared. That gives me 4 of the a's being multiplied. So 2 times 2 equals 4. So I get a to the fourth power. I got to be careful with that. That's like one of the places where 2 times 2 and 2 plus 2 both equal 4. So let's look at this one so we make sure we understand the property. This is b to the third power times b to the third power. That gives me a total of 6 b's that are being multiplied. So that is b to the sixth power, which you can also get from 3 times 2. All right, so I only have a show up once, I only have b show up once, and I've simplified everything, no parentheses. I'm good to move on. So if you, I'm not going to keep saying this, but if you want to pause before I do problem number 11 and try it yourself, do that. Okay, for problem number 11, these parentheses aren't really doing anything the way that they're written. Okay, parentheses are useful, but this is still c to the third d to the second times c to the negative 2 times d to the fourth. I just have 4 factors that are being multiplied. So I'm going to put the c's together and I'm going to put the variable d together, right? So my first step, which you don't even have to write this when you do it. I'm doing it because I'm in explain teacher mode, okay? But my first step, I'm going to rewrite this in order. So I'm going to put the c's together. So I get c to the third times c to the negative second power, and then I'll put the d's together. D to the second times d to the fourth. Now, if I've got c to the third times c to the negative 2, which actually that's the same as c to the third divided by c to the second power, all right, which is just going to equal c, which is c to the first power. So if you think of it this way, that's fine. You're understanding what negative exponents do. Negative exponents, well, sorry, even with the negative exponent, I can add the exponents together when I multiply. So 3 plus negative 2 equals 1. So this is c to the first power, like I showed over here. 2 plus 4 equals 6. This is d to the sixth power. If I expanded that, that would be d times d for d squared times d times d times d times d, right? Which gives me d to the sixth power. And one question that comes up is, do you have to write the 1? Obviously not. Usually we don't. But like I said previously, you can always show things in my class that are hidden. I'm not going to mark that wrong. It tells me, it communicates to me that you understand what you're doing, which I think is appropriate. All right, let me scoot up just a little bit. All right, for this one, I'm going to break this into a couple of different parts, right? Like I just said about hidden stuff, there's a hidden number 1 right here. So I'm going to do the constants. I have 5 divided by 1 times u divided by u squared times v to the sixth power divided by v to the second power. 5 divided by 1, we know what that is. There's a hidden 1 here. This is the quotient property, so I'm going to have 1 subtract 2, which is negative 1. This is the same as if I expanded, I had u divided by u times u. These are going to reduce, leaving 1 over u. So I'm still going to have that u in the denominator. That's the same as u to the negative 1 power. So I'm going to have 5. I'm going to have the remaining u in the denominator. And then for the v's, 6 subtract 2 equals 4. So, and those are in the numerator. So I have v to the fourth power. If you had written 5 u to the negative 1 power, v to the fourth power, we want to make sure that even though negative exponents exist, usually when we talk about simplifying or best form, we want to write it like this, okay? Problem number 13, so pause if you want. The 10 is on the outside of the parentheses. Only what's inside parentheses has that exponent. So the 10 is going to get left alone for a moment, and I'm going to have y to the fifth power to the second power divided by x to the second power to the second power. So this is the power of a power where I multiply the exponents just like I did up here, and I get 5 times 2, which is 10. So I'm going to write 10 times y to the 10th power divided by 2 times 2 equals 4, x to the fourth power. And the way I wrote it, I wrote the 10 kind of like a little higher. Don't worry about that. If I wanted to draw this like that, that's fine. Or I could have written it the way it was given, y to the 10th power, x to the fourth power. That would have been okay too. All right? So now I'm going to switch over and do the last 4 problems. Don't be scared. You got this. So try to do the problems before I show you if that's what you want to do, right? So I got a lot going on here. I got negative 2 times s to the negative third power times t times 7 times s to the negative 8 power times t to the fifth power. Whew, that's a lot. I'm going to put the constants together. Everything is just being multiplied here. That's all that's happening. And I like you may have noticed that when I did that problem, and even that one, I like to put the multiplication dots in just because it seems to make it a little bit more clear when I'm explaining it. It's not something that is necessary, obviously. It's actually best form without the dots, but I like to do it when I'm explaining. So you're going to see me write a little bit more than when I'm explaining stuff. So I'm going to write negative 2 times 7. Then I got s to the negative third power times that s to the negative 8 power. And then I got t, and that's t to the first power. So I'm going to show that hidden exponent, times the other t to the fifth power. Okay, cool. Now I'm going to put these two together, these two, and these two. Negative 2 times 7 is negative 14. Easy peasy. When I multiply and I've got a product here, I'm going to add the exponents. Negative 3 plus negative 8 is negative 11. So I have s to the negative 11 power. And then same thing with here, 1 plus 5 equals 6 times t to the 6th power. And like I said in one of the previous problems, simplified form means that one of the things to simplify is no negative exponents. There's nothing wrong with negative exponents, it's just it's not simplified. So the final step would be negative 14 t to the 6th power and s to the positive 11 power in the denominator. Problem number 15 looks a lot like that one, except I've got that exponent, so I got to deal with that first. So the negative 4mn, I'm going to leave that alone for right now. This is m to the third power times n to the second power to the third power. So that exponent 3 gets shared with the m and the n squared. I know, I don't know why we put m and m's together like that. So I'm going to take care of these exponents, and then we're going to put everything together. So I still got negative 4m times n. I'll put the dots in, times m to the third power times n, 2 times 3 equals 6, n to the 6th power. So now let's put all these together. How many, the negative 4 is still good. How many m's do I have? I've got 1 and 3 more over here. So that gives me m to the 4th power. How many n's do I have? I've got 1 here and 6 more over here. So now I've got n to the 7th power. Okay, moving on to problem number 16. Let's take that exponent in the top. I get 4 to the 2nd power, b to the 2nd power, all over 2b. And I'm missing you guys in class because when I say 2b, I kind of pause and wait and see if anyone catches it. The joke is you're supposed to respond with or not to be. Miss Osendorf would be proud of me. All right. This is going to be 4 squared, which is 16. This is b squared all over 2b. Now, before we're done, let's simplify. 16 divided by 2 equals 8. And b to the 2nd divided by b, 2 minus 1, because the exponent is 1, is just 1. So I just get b. If you want to write b to the 1st power, I'm cool. Or you can just write 8b. And finally, problem number 17. We've got negative exponents in the top. We know that that means reciprocal, so they actually move down to the bottom. These are in the top. What happens if I have a negative exponent in the bottom? This is confusing. So let's go back to what our properties are. Okay? So remember, when I have a quotient with exponents, that I'm going to subtract the exponent. So this is going to become x to the negative 1 minus 3 power. I also have y to the negative 2 over y to the negative 5 times y to the negative 2 subtract 5. Oops, excuse me, sorry. I didn't put enough space in there. Subtract negative 5. Sorry, sometimes I have to look at it again, make sure I catch my mistakes. All right, so negative 1 minus 3 is negative 4, and 2 subtract negative 5. Remember, I talked about this earlier. Subtraction is redundant. We really don't need it. This is the same as adding the opposite, so I get 2 plus 5. So I get y to the 7th power. And that negative 4, again, that the exponent was negative 4, that tells me the reciprocal. So my final simplified form here is y to the 7th divided by x to the positive 4. Okay, that's a lot. Rewind it, pause, look at the slides so you can see what's going on. Maybe you went about it like in a different path and ended up in the same place. That's what happens with these properties. So hit me with questions in the discussion if there's something that you didn't understand. Good luck.